Okay, so in this section, we are going to talk about linear inequalities in two variables. So a solid line should be drawn if the original inequality contains a less than or greater than with a line underneath it. So greater than or equal to, less than or equal to. And a dashed line should be drawn on our graph if the original inequality contains a less than or a greater than symbol. So if it has the equal to, it'll be a solid line. If it has no equal to part, we're going to have a dashed line. So the half planes, those are going to be two regions divided by a line. The left and right planes are divided by a vertical line. And the upper and lower half planes are divided by a non-vertical line. A boundary line is going to be the line that divides each half plane. So if we have our graph and we have a line going this way, this is our left and this is our right half plane. If we have a line going this way, we have an upper and a lower. And those will be boundary lines that divide them. So for graphing linear inequalities, first we're going to find the intercepts to graph the points and draw a line. We can use 0, 0 to test which half plane is shaded. We choose that because it is the easiest one to plug in and to test on. If it is a horizontal or vertical inequality, then the graph of the horizontal or vertical line. So you'll have just, if it's a vertical, it's going to be just that. We can use the 0, 0 to test which half plane is going to be shaded. Finding the linear inequality from a graph, find the x and y intercepts. Use the intercepts to find the slope and use the 0, 0 point or the origin to test the points to determine if it's greater or less than. Remember, it's going to be dashed or a solid line for the parts that have the equal. We have our slope formula. Remember, that's going to be m equals your y2 minus y1 over x2 minus x1. Basically, that's going to be our rise, the change in y, over the run, which is the change in x. And again, on your exams, all formulas will be provided one way or another. Slope-intercept form is an equation of a line that has slope m and y-intercept of b. So 0, b, because it is the y-intercept. And when the y-intercept, x is equal to 0. And we have the equation of a horizontal line will be y equal to the b. And the equation of a vertical line is x equal to a. We have 4 quadrants in our graph. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, every x and y are positive. Quadrant 2, our x's are negative, but our y's are positive. In quadrant 3, both x and y are negative, and in quadrant 4, x is positive, y is negative. All right, so let's go graph some graphs. So this is 5.1, and for example 1, we are going to graph the inequality. And our inequality is y is greater than or equal to x minus 6. So the first thing we want to do is find our x-intercepts. So for the x-intercept, we set y equal to 0. So y is equal to 0. We're not going to use the greater than or equal to. We're using the equal, x minus 6. We'll add 6 to both sides and get x equal to 6. So our intercept point will be 6 for x, 0 for y. For the y-intercept, x will be equal to 0. So we'll have y equal to 0 minus x, or minus 6, so y equals negative 6. So our point will be 0, negative 6. 0 for our x, negative 6 for our y. The next thing we need to do is a test point. And remember, we're going to choose the origin, or 0, 0. So we're going to plug that into our graph. So y is 0, greater than or equal to x0 minus 6. And we're looking to find out, is 0 greater than or equal to negative 6? Well, that is a true statement. So that means that our 0, 0 is in the solution. Okay, that's what that tells us. Because we get a true statement, it'll be in it. If the statement was false, 0, 0 would not be in it. All right, so let's graph. We have 6 and negative 6. So we draw our graph here. We need 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Because those are the points we have. We can add some other dashes over here, but they won't matter a whole lot. Here's our x and here's our y. All right, so we've got 6, 0. We've got 0, negative 6. We're going to draw our line. We have an equal to, so it will be a straight line. If it was not equal to, but just greater than, we would do a dashed. So we're going to draw our line. And then we know that 0, 0 was in our solution. So that means this area here will be shaded. All right, let's go on to example 2. We are going to graph x is less than or equal to 8. Now, this is not a y equals mx plus b graph now. This is just an x, if we look at that, equal to 8. So that's our vertical line. This will be a vertical line graph. So vertical line through x equal to 8 is what this graph will be. Now, we still have to do our test point, but we don't need to do x and y intercepts because we don't even have a y value. So let's do our test point. And again, that's going to be 0, 0 because it's the easiest to plug in. So we'll plug in our 0 for x. So we'll have 0 less than or equal to 8. Well, 0 is less than or equal to 8. So that tells us that 0, 0 is in the solution. So let's draw our graph again. We don't need a very tall graph because we just need an x equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. It is a greater than or less than or equal to, so it is a solid line. And then we're going to shade this way. And that's all you have to do on example 2. All right, let's go to example 3. So for example 3, we are going to graph 8x plus 3y greater than 24. So what we notice on this one is we don't have a line underneath it, so it is not going to be a solid line. This one will be a dashed line because we are looking at not a greater than or equal to, but just a greater than. All right, so next step we've got to do is the x-intercept. And of course, that's when y equals to 0. So we'll have 8x plus 3 times 0 greater than 24. Anything times 0 is 0. That, whoops, and we need to put that equal to, so sorry. So equal to 24. So 8x equals 24, divide by 8, because we're trying to solve what the x-intercept is. 24 divided by 8 is going to get us 3. So that tells us that our point will be 3, 0. All right, let's do the y-intercept. Y-intercept, x equals 0. So we'll have 8 times 0 plus 3y equal to 24. 3y equals 24. Divide by 3. Y will be equal to 8. So we'll have 0, 8 as our y-intercept. And then we have to do our test point. And again, we're going to choose the origin of 0, 0. So we'll have 8 times 0 plus 3 times 0. Is that greater than 24? Well, 8 times 0 is 0, plus 3 times 0 is 0. We can step it out if we want, or you can just go straight to 0 greater than 24. This is a false statement. This is not true. So it's gonna not in solution. So when we do our graph, 0, 0 will not be in our solution. All right, so we've got to go 8 on the y, so we're going to be up, and 3 on x. So I don't need a very tall bottom part of our graph, but I need a tall part up here. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. And I'm going to do one past that because I know that 0, 0 is not in my graph. All right, so we have our 3, and we have an 8. And remember, this is not a solid line. It's going to be a dashed line. So I'm going to kind of dash it through. And 0, 0 is not in our graph, so we're going to graph this way. All right, so for example 4, we are going to state the linear inequality from the graph. Okay, so I changed some numbers. I forgot to change this one. I will make sure I change it in yours, so this should be example 4. We're going to state the linear inequality whose graph is given in the figure. Write the boundary line equation in the form of ax plus by equal to c, with a, b, and c integers, so that should be a capital C as well, before stating the inequality. All right, so we've got to look at our graph here, and we're going to pull off the intercepts. So we have an intercept here, and we have an intercept here. So our x-intercept is at the -3, so it'll be -3, 0. Our y-intercept is at -2 on our graph, so 0, -2. And I can show you again. So x-intercept is right here. That's at -2, so -3. And the y-intercept is right at -2. And you should have your graph there on your handout to look at. All right, so remember we're looking at y equals mx plus b. We now know that because we have the y-intercept, we know that this will be -2. But we still have to find the slope. So how do we find the slope? The slope will be found by the 2 points that we have. So remember our slope formula, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It doesn't matter which point you make the first point or the second point, but I'm going to label these so we know that this is x1, y1, x2, y2. And it doesn't matter. We could make this the second point, not the first point. Doesn't matter, as long as you go the same direction in each point. All right, so we'll get -2 minus 0 over 0 minus -3. And that's what I mean by going the same direction. If we start over here and go there, we have to start over here and then go here. We have a -3, but the formula has a minus, so make sure you're watching that because that will then become a positive. So this will get us -2 minus 0, which is -2. This will become +3, so 0 plus 3 will get us 3. So that's our slope. So now we have our equation will be y equals -2/3 x minus 2. Okay, so that would be the equation of the line. It says state the linear inequality. Write the boundary line equation in the form, so that's our boundary line equation, before stating the inequality. All right, so where do we go from here? Well, we've got this. We've got the boundary line, or not the boundary line, but we've got like an equation of the line here, but now we need to transform it. So let's find our boundary line. And we need this to be in ax plus by equals c format. All right, so we have our y equals -2/3 x minus 2. So I don't want to see the slope. I actually want to kind of remove the slope. So what I'm going to do is multiply both sides of our equation by 3. So this will leave us with 3y equals 2. 3 times this 3 will cancel, times the slope here will cancel the 3 out. We're left with -2x, and then 3 times -2 will get us -6. We have to multiply the 3 by both parts of our equation. All right, now I have my y's over here, but I still need the x's over there. So I'm going to add 2x to both sides and get 2x plus 3y equals -6. This is the boundary line equation. All right, now what I need is still my linear inequality. So linear inequality. All right. Now, let's look at our graph for a second. Do we have a solid or a dashed line? Because we have a solid line, we know it's an equal to. That's what we know for that. We also look at the test point. Now, it's graded. It looks like it's shaded there. If we look at, but we can test it if we're not sure, right? If we're looking at the inequality and we're like, well, is that shaded or is it not shaded? I don't know. I can't tell. Now in your homework, you should be able to tell. But we can look at the test point and see if it's true or if it's false. So let's see what our, let's look at the test point part. Remember, we're going to test 0, 0. And we've got to test it 2 ways. We need to test it on the less than or equal to and the greater than or equal to. So we're going to take our equation of 2 times 0 plus 3 times 0, and we're going to say is it less than or equal to -6. So again, we get 0 plus 0. So 0 less than or equal to -6, this is false. All right, so let's do the other test point. So if we do 2 times 0 plus 3 times 0 greater than or equal to -6, we still get our zeros. Is 0 greater than or equal to -6? Well, yes, it is. So this one is true. So that tells us that 0, 0 is not in the solution region. So our 0, 0 is not in our solution on the graph, right? It's down here. So because it's not in the solution, the inequality is false. So we're actually looking for this one here. We're looking for the false because 0, 0 is not in there. So our inequality is going to be 2x plus 3y less than or equal to negative 6. And you're like, whoa, what just happened? We said it was true for here. If the solution set, which is what we looked at, it's shaded down here, right? So it's kind of hard to tell on the graph. But it is shaded down here. So 0, 0 is not in the solution set because our shading is down here. So because this makes it true that it is in there, then it cannot be this one. This one says, no, it's not in the shaded region, which is what we want, not in the shaded region. So that's why we picked that one. Okay? If it had been shaded the other way, we would have looked for this to be in it, and we would have chosen this inequality. All right. So here, this one's going to be number 5 now. We're going to write the inequality whose graph is given. All right, so we're looking at the boundary line is a horizontal line going through our y value of 4, so 0, 4. So let's change our page here. So we know that the boundary line is goes through zero, 4. So because it's a horizontal line, we know it's y equal to 4. Now, again, on the graphs, it's a little bit hard to see because of the way things print. But our 0, 0 is not shaded. We're shaded up here at the top. So because 0, 0 not shaded, we are looking for the false, right? So we're going to do our test point. So we've got y greater than 4 we need to test, and y less than 4. So we have 0 greater than 4, and we have 0 less than 4, because we don't have an x value, we're just plugging in the y. Okay, this one, 0 is not greater than 4, and here 0 is less than 4, so that makes that one true. Now, since that 0, 0 is not shaded, it must make the inequality false. Because it's not shaded, and our shading is more up in this part right up here, and I could tell that, but it might be hard to see on the graph on yours. So this part is graded, or shaded. Then we want that false again. So y greater than 4 is the correct inequality. On your homework, you'll be able to truly see the graph and whether or not it is shaded. All right, let's look at example 6. So example 6 tells us to graph the inequalities subject to the restrictions. X greater than or equal to 0 and y greater than equal to 0. It just tells us that we're in the positive range. So we're going to be in that first quadrant with x and y both have to be positive. All right, so example 6. We are going to graph 7x minus 20y less than or equal to 1400. And we have x greater than 0 and y greater than or equal to 0. Both of them greater than or equal to. Okay, we're going to do it the same way we've done before. First thing we're going to do is find the x-intercept and the y-intercept. Again, x-intercept, y equals 0. So 7 times x minus 20 times 0 equal to 1400. 7x equals 1400. Divide by 7. X will be 200. So the point will be 200, 0. And then our y-intercept, where x is equal to 0, we will have 7 times 0 minus 20y equals 1400. So negative 20y equals 1400. Don't forget that negative sign. That's where a lot of students make an error there. So divide by negative 20, and y will be equal to negative 70. So we will have 0, negative 70 as our x-intercept. Our y-intercept. I was thinking I didn't box the x-intercept. So those are the 2 points that we have. And then we're also going to need to do the test point. Again, we're going to do 0, 0. So 7 times 0 minus 20 times 0 less than or equal to 1400. We've done a few of these, but again, 7 times 0 is 0. Negative 20 times 0 is 0. So we get 0 less than or equal to 1400. This is true. So that tells us that our 0, 0 will be in our shaded area. All right, so let's graph this guy. So we have some big numbers. I'm not going to put 200 hash marks. I'm going to count by 50s to make it kind of even. All right. So 1, 2, 3, 4, 5, 6. These will be counting by 50s. All right, so this will be like 50. This would be 100, 150, and so forth. This will again be 50. This will be 100. This would be 200. And then this would be negative 50 and negative 100. All right, so we know that x is at 200 and y is at negative 70, so about right there. And we have a straight line, not a dash, because, or a solid line, because we have the inequality of greater than or equal to. So we're going to draw a line best we can here. And we know that we also have some limitations here of the x-axis and the y-axis, because it had to be greater than or equal to and greater than or equal to for both x and y. So we are not going to shade everything. We're going to shade up into those axes. So that would be our shaded area. And our line will continue, right? It'll continue over. All right. And so that puts our answer into quadrant 1 because of the positives. Okay, so let's go look at our last problem, which will be example 7. So we have seed costs for a farmer are $50 per acre for corn, $60 to $4 per acre for soybeans. How many acres of each crop should the farmer plant if she wants to spend no more than $6,400 on seed? Or express your answer as a linear inequality with appropriate non-negative restrictions and draw its graph. All right, so let's write down what we know. So this will be example 7, and we're doing corn and soybeans. So x is going to equal our acres planted with corn, and put y as the acres planted with soybeans. All right, so on our problem, we had 50 acres for corn. So that's going to get us 50x, or $50 per acre for corn. And we had $64 per acre for soybeans. So our cost here will be 64y. Okay, and we know it has to be non-negative because it told us to make sure we are non-negative. All right, so for the inequality, we'll have 50x plus our 64y, and it said that we couldn't spend more than $6,400. So that has to be less than or equal to $6,400. Now the non-negative part tells us that x will be greater than or equal to 0 and y will be greater than or equal to 0. And let's think about that. If we're planting corn or soybeans, we either plant 0 acres or more, like, so we're going to do more than 0, or we can't make a negative acre of our planting. So that's why that's going to definitely be a non-negative number. All right, so we've got our inequality right there. These are going to be what we're looking at for our problem, and we're going to go do just what we did before. We're going to go find our x-intercept, where y equals 0. So 50x plus 64 times 0 equal to 6,400. So 50x equals 6,400. We divide both sides by 50, x will be 128. So we have 128 comma 0 as our x-intercept. Let's go do our y-intercept. This will be where x is equal to 0. So 50 times 0 plus 64y is equal to 6,400. So 64y equals 6,400. Divide both sides by 64, and y equals 100. So our part will be 0, 100 for our y-intercept. Now, we still need to do our test point. So our test point is still going to be 0, 0. So we have 50 times 0 plus 64 times 0 less than or equal to 6,400. So this will get us 0 plus 0 less than or equal to 6,400. 0 is less than 6,400, or less than or equal to. So it's going to be true. And again, you don't have to write the 0 plus 0. You can just go straight to the 0. So this will be true. Now, that greater than or equal to tells us we're going to have a solid line, not a dashed line. But because of our greater than 0, the answer will still be in quadrant 1. All right, let's draw our graph. So we've got two positive numbers, so I need a very low one down here. I need to go to 100, and I need to go 128. I think I'm going to go by, let's go by 25s. So we'll do 25, 50, 75, 100. We could have done by 10s, you could have done by 50s, it doesn't matter. As long as you try to keep it equal. All right, so we'll have 25, 50, that's a little wide, but that's okay, 75, 100, and then 125, and 150. This is our x, and this is our y. All right, so y-intercept, x-intercept at 128. And we're going to get a straight line. And this will be in our solution, the 0, 0. Solid line. And we're going to shade in here. So that is where our graph is.